Chapter 8, Section 7 in the 7th grade workbook is entitled Classifying Quadrilaterals. The top part of the worksheet, questions 1 through 6, all have the same set of directions. They're asking me to give all the names that apply to each quadrilateral and then give the name that best describes it. So of course we need to have some perspective on what our options are here. So let's go ahead and take a look at that same quadrilateral image map that you saw in class today. Quadrilateral is a generic term that describes any four-sided figure. Now out here to the left on the quadrilateral image map, you have a shape that has no parallel sides. And it's the only quadrilateral that has no parallel sides. It's called a kite. It doesn't look anything different than what you would picture the word kite to look like. Here in the second drop down from quadrilateral, you have the only quadrilateral with one set of parallel sides, and that's called the trapezoid. There is a very specific type of trapezoid that is not included on this illustration, but if the left and the right side of the trapezoid would happen to be the same, then it would be called an isosceles trapezoid. But here this is just a trapezoid because the top side happens to be parallel to the bottom side. And then as we come over here to the far right side of the quadrilateral image map, where things definitely start to get more complicated, that's called it begins with the idea of a parallelogram, where we have opposite sets of sides parallel, meaning two sets of parallel sides. So we have the top and the bottom here being parallel, and the left side and the right side being parallel. And that is true for any shape over here on the right side of this illustration. Now where it goes from there kind of depends. If you end up here with right angles in your parallelogram, with the opposite sides parallel and congruent, then you have a rectangle. If you were to happen to have opposite sides just congruent, you would have a rhombus. And if you bring those two ideas together, where you have right angles and opposite sides congruent, then you end up with a square, which is why you can see those two are feeding together down here at the bottom for a square. It is quite possible that your answers may end right here. If it's just a parallelogram but it doesn't have either of these features, the answers end over here at parallelogram. However, they could continue on down the trough and include multiple answers from this side. It could be 2 or 3 possible answers, or many answers from that side, depending on how the shape is perceived. So let's go ahead and take a look at question number 1 there. Now they're asking me again to give the names that apply to the quadrilateral. Well, obviously we can see from the right angles and from just our knowledge of basic shapes that that does look to be like a rectangle. So if we look over here at the quadrilateral image map, that means this shape also has to be a parallelogram, because the only way to get to rectangle is to go through being a parallelogram. Parallelogram just has opposite sides congruent and parallel. And indeed in a rectangle, these two sides are congruent and parallel. These two sides are congruent and parallel. So this one is going to be a parallelogram and a rectangle. And as far as giving the name that best describes it, when we go over to that right side of the chart, we're looking for really the name that's furthest down the trough here as far as naming rights goes. So the most specific name for this shape, the best name for this shape, is indeed a rectangle. As we go ahead and take a look at question number 2 here, we have opposite sides congruent and parallel. So as we feed down the trough here, this is the set that has two sets of sides being parallel, so this is a parallelogram. It does not have all 4 sides congruent. It does not have right angles, so all these are out. So again, this one just ends at parallelogram. That's all this shape happens to be. And as we look at question number 3 here, in question number 3, this looks a lot like what we did in question number 1. It just has sides that look like they're bigger, so this is going to match number 1 exactly. This is also going to be a parallelogram because it is a rectangle. And the most specific name, again, the one that's furthest down the trough here, is going to be rectangle. Now as we head towards the bottom of the page here, now they're asking me to draw a figure, and if it's not possible to draw it, then explain why it's not. So here they're asking me to draw a rectangle. Number 7, draw a rectangle that is not a parallelogram. Well, if we go back and look at our chart again here, we know that in order to get to be a rectangle, you have to first feed through parallelogram. So if they're asking me to draw a rectangle that's not a parallelogram, that's simply not going to be possible, because here, in order to get through parallelogram, you have to get to rectangle, you have to go through parallelogram. So this is not possible, which is probably kind of obvious based on how many lines were there, but it's not possible because all rectangles are parallelograms. Remember, what makes a parallelogram here is it has opposite sides, congruent, and parallel. Opposite sides are equal, same length, and they run parallel. If they drew them forever, they would never intersect. So here, and that's going to be true here in both the rectangle and the parallelogram. Now, as we take a look at question number 8, they're asking me to draw a rectangle that is not a square. Well, we know the difference between these two shapes, and we can even see here a rectangle. What's true about a rectangle? Well, the opposite sides are congruent in a rectangle. But in a square, all the sides are congruent. So I just want to make sure I draw this so that the opposite sides are congruent, but not all 4 sides are the same. And this is nothing different than what you would already know, so this really shouldn't be a big deal. And we can draw this a lot of different ways, but I'm going to go ahead and draw a 2x4 rectangle here on the dot pattern. And there's a rectangle that is not a square. It has the right angles, it has the opposite sides congruent and parallel, but what's true here is that the sides are not all exactly the same. So there is a rectangle that happens not to be a square.